Hello friends, welcome back. Today's topic is water cement ratio, or what is WC ratio and what is the significance of WC ratio, and most importantly Duff Abrams law of water cement ratio. Now what is water cement ratio? This is the ratio of weight of water to the weight of cement while preparing a concrete mix. That is, if we are preparing a mix with 50 kg of cement and we take 20 kg of water, then 20 divided by 50, that is 0.4 will be the WC ratio. Similarly, for a 50 kg of cement, if we take 30 kg of water, then 0.6 will be the WC ratio. One thing is to be noted that water and cement both are taken in weight while finding out a WC ratio. Yes, this can further be converted into volume using the bulk density of that cement. Water cement ratio is one of the very important factors during the preparation of a concrete structure. The quality of cement always can't be blamed for a weak concrete structure, because if WC is higher, that is, the quantity of water is more, this can be understood by the slump test. If the slump is shear slump or it's a collapse slump, that means water cement ratio is higher. Then there will be segregation in concrete mix. Segregation is the separation of coarse aggregates from the rest of the mix. In this case, the coarse aggregates separating from the rest of the mix come to the lower side of the structure and leave lots of voids, which makes the structure very weak. Again, if WC is higher, then the case of bleeding is observed in the concrete. As the quantity of water is higher, then the excess water starts evaporating, leaving voids inside the concrete structure. Because of these voids, the plastic cracks develop on the structures. These cracks are often observed parallel to the reinforcement bars. And finally, due to these voids and cracks that develop due to higher water cement ratio, make the structure weak. Now, in case the water cement ratio is lower, then the main problem arises in workability. That is, due to the less quantity of water, it becomes tough to work with the concrete mix. It is also not very easy to compact the concrete mix which is having less quantity of water. Now again, if the water cement ratio is lower, less water remains available for the hydration of cement. That's why incomplete hydration is noticed if water is used less. That is, WC is lower than what it is actually to be. Thus, it is never to compromise with the water cement ratio, because both the higher and lower WC ratio is detrimental to a concrete structure. Now the question is that what should be the WC ratio, or what is the preferred water cement ratio? The preferred water cement ratio is 0.4. The reason is, while preparing a concrete mix, when water is added, the hydration reaction starts as soon as water is added. During this reaction, we know that CSA gel starts to form, which gives further strength to concrete structure. Now, what's the water requirement for complete hydration reaction? Water of about 23% of quantity of cement is required for complete hydration of that cement, and additional water of 15% of the quantity of cement is required to occupy the CSA gel pores. These 15% of water is entrapped in the CSA gel pores and hence can again contribute for the hydration of the cement. Thus total water requirement is 23% plus 15%, that is 38%, or in fraction it is 0.38, which is approximately 0.4. Now with an example, if we are using 50 kg of cement for preparing a concrete mix, then we will first require 23% for complete hydration of that cement. That is, 23% of 50 kg is 11.5 kg of water, and the additional 15% which was to be entrapped in the CSA gel pores is 15% of again 50 kg, that is 7.5 kg. The total of 19 kg of water is required for 50 kg of cement. Thus, in summary, we can say that if water cement ratio is greater than 0.4, then there will be literally excess of water, and hence there will be a capillary rise of excess water which causes bleeding of concrete, and because of that voids remains inside the concrete mix, which result the development of cracks in the early stage of hardness of that concrete structure. And if water cement ratio is less than 0.4, then there will be a problem in workability, there will be a problem in compacting the concrete, and there will be incomplete hydration. And because of all this, there will be low strength development in the concrete. Now, what is Abrams Law of water cement ratio? Abrams Law states that with the given concrete ingredients and test conditions, the quantity of mixing water used alone determines the strength of the concrete, so long as the concrete mix is workable. In simple words, the strength of the concrete depends upon the WC ratio provided to the mix, and numerically it is stated as S equal to A by B to the power X, where S is the 28 days compressive strength, A and B are imperial constants, and X is the water cement ratio. Thus, with S equal to A by B to the power X, it is found that as water cement ratio increases, the strength of the concrete mix decreases. It is also found from compressive strength versus water cement ratio graph of Abrams that at the same water cement ratio, vibration gives more strength than hand compaction. At the same time, there is a limitation found in Abrams law, and it is that it didn't consider the effect of entrapped air on the strength of the concrete, whereas strength of the concrete is greatly affected by the presence of entrapped air, such as 5% of voids due to the entrapped air can lower the strength up to 35%, and mere 2% of voids can reduce the strength of the concrete up to 10%.